Good morning, everyone. I will give a presentation on the Beidou real-time precise products from Wuhan University and its application in NBus. And this is actually a joint effort of me and my colleagues. My name is Senfeng Gu, and from the GNSS Research Center of Wuhan University. Today, my presentation is divided into 4 parts. Firstly is an overview of the background, and then we come to the evaluation of the Beidou real-time precise products evaluation. And in the third part, we will use these products in the real-time PPP, and finally we come to the summary. We start with the introduction of the current status of Beidou. Last year, 2 new Beidou 2 satellites have been launched, and their footpoints are shown in this picture, in which one is the IGSO satellite and the other one is the GEO satellite. Now the IGSO satellite is in active status. However, the GEO satellite is still under test. With the new active IGSO satellite, the positioning performance is analyzed by SPP here. We can see from this table, the precision of SPP is improved by about 5% for both horizontal and vertical. The result is averaged over these stations. Regarding the performance of PPP, the new IGSO satellites also contributes to accelerate the confidence time, as shown in this picture. The statistic suggests that the improvement is about 18% on average. Moreover, with the intention of global coverage, 5 Beidou 3 satellites have been launched over the past 2 years, and most of them are in active status. However, the broadcast ephemeris are not publicly available, so the evaluation of their contribution to the positioning is left for future study. From the above introduction, we know that the standard positioning precision of Beidou is at a level of 7 meters in its current stage. Well, with the development of Beidou system as well as the requirements of the high precision applications based on Beidou, the national Beidou augmentation surface system is under development. There are about 150 multi-GNS stations as a national backbone frame, and about 1,200 multi-GNS multi-densified reference stations in special areas. All the measurements of these stations will be connected by the National Data Processing Center in real time to generate the precise products. And then these products will be broadcast to the users through the application service centers. In the first step, the augmentation system is focused on the Beidou and the GPS, and in the near future, the GLONASS and Galileo will also be included. This slide gives the distribution of the tracking station network for Beidou Beidou real-time service, among which there are about 72 stations for orbit determination and 92 for the clock estimation, and 150 stations for the generation of regional products. Based on above real-time data stream, multi-GNSS precise orbit determination will be performed in a bench solution manner, and then is the clock estimation at a resolution of 1 second. Based on these products, the wide area precise positioning can be achieved through the PPP technique. Well, we have also generated the real-time aerosphere and troposphere collections to improve the performance of the PPP within China based on the density network. Okay, we come to the evaluation of these products. Firstly, we come to the orbit. The left side is the results of GPS, and the right side is that of Beidou. As shown in this table, the GEO satellites has the orbit precision of GEO satellites is worse than IGSO and MEO, which is about 10 centimeters for close and radial. Where for IGSO and MEO, the precision is better than 10 centimeters. As a reference, we also calculate the GPS results, which is better than 3 centimeters. To invariate the performance of satellite clock, we, by taking the high correlation of clock bias and orbit bias, we choose to use URE to invariate the clock precision. The URE can be retrieved from this equation. Here, dA, dC, and dR is the orbital difference with respect to the GFC final product. D clock is the clock difference with respect to GFC final product, and then we combine all these differences to produce the URE. And showing these two pictures are the bias and STD for URE separately, as shown in the first picture. The bias of IGSO and the MEO satellite is at a level of 1 meter, which is much larger than that of GPS. This is mainly due to that there are fewer stations tracking the IGSO and the MEO satellites. And for the URE-STD, they are at a, they are at a level of, most of them are better than 2 centimeters. Here, this slide shows the statistical results of real-time Chinese aerosphere map. About 100 stations, real-time measurements are collected to generate this map based on harmonious spheric functions. And the resolution is the time resolution is about 30 seconds. To invariate the above real-time sim products, about 200 stations. These stations are independent with the stations used for the modeling. The 200 stations measurements are processed in PPP mode to generate the VTEC as a reference. The result is about 3.4 tech units, and as shown in this picture, actually most of them are better than 3 tech units. Regarding the result of troposphere products, the ZTD retrieved from an independent network of stations are regarded as a reference to assess the precision of real-time tropospheric grid points model. 4 weeks observations from different seasons are selected to demonstrate the seasonal behavior. As we can see from this table, for winter and spring, the precision is about 1 centimeter, and for summer and autumn, it is better than 1.5 centimeter. As a reference, we have also calculated the result with the GPT-2 model, which is about 3.5 centimeter on average. This suggests that we can benefit from the density network to provide the real-time tropospheric directions. To demonstrate the performance of the above products in the application of precise positioning, real-time results of 26 stations distributed over China for this period are collected and analyzed in both of accuracy and convergence. This slide gives the Beidou frequency PP accuracy, from which we can see that for the vertical direction, it has a precision of better than 8 centimeter, and for horizontal, it is 3 to 4 centimeter. When the same data sets are used also for the Beidou and the GPS combination frequency PP, which the precision is improved to about 3.4 centimeter for vertical and better than 2 centimeter for horizontal. For single frequency PPP, the results suggest that we can have a precision of half a meter for vertical and about 2 to 3 decimeter level for the horizontal direction. When it combined with the GPS, the result is that for vertical it is 0.3 meter and 1 to 2 decimeter for horizontal. Also, there are a great number of single frequency SPP users over China, so we have also tested the performance. For Beidou only single frequency SPP, the result is 1.6 meter for vertical and better than 1 meter for horizontal. When combined with GPS, vertical is 1 meter and for the horizontal is about half a meter. This slide gives the overall statistic of the above result. We can see that when combined the GPS and GLONASS and Beidou, it gives the best performance. Competence is also a key issue in PPP. And we can see from here, for dark frequency, Beidou only takes over 1 hour to get a precision of centimeter level. Well, when we use GPS or Beidou combined with GPS, it only takes about 15 minutes. For single frequency PPP, the best performance can be found from the combined GPS Beidou result, as shown in the green line. Also, when we use the real-time tropospheric grid points model to the Beidou dark frequency PPP, we the horizontal components can be improved slightly, while for the vertical components it can be improved significantly, since that the troposphere delay is highly correlated with that of vertical. Okay, we come to the summary. For the N-bus system can provide precise orbit and clock paths as well as the regional as well as the aerosphere and troposphere delays for over China with high precision to support the 10 centimeter level dark frequency PPP as well as decimeter level of single frequency PPP. I think that's all.